Hello everyone, welcome back to another physics lesson. I'm Physics Michael, and today we are going to explore an important concept in vector mathematics, combining vectors. We will start with combining displacement and velocity, and then explore the rules of adding and subtracting vectors. Since these rules are crucial for solving problems in physics, let's dive in. Before we start adding and subtracting vectors, let's quickly review what vectors are. A vector is a quantity that has both magnitude and direction. This is different from a scalar, which has only magnitude. You may still remember the case before. Here, mass is a scalar, it has no direction. On the other hand, force is a vector because it must have a direction. So, displacement and velocity are vectors as well because they both have directions. Now let's start with vector addition, using displacement as an example. Imagine walk 6 meters north, then turn and walk 8 meters east. What is your total displacement? You might think it's simply 6 plus 8 equals 14 meters, but displacement is a vector, so we have to consider the direction. To find the total displacement, we draw the first vector, 6 meters north, and then draw the second vector, 8 meters east. By joining the tail to tip, the resultant displacement is the straight line distance from the starting point to the final end point. This forms a right-angled triangle, and we can use the Pythagorean theorem to find the magnitude and direction of the resultant displacement. In this case, the displacement is 10 meters at an angle of 37 degrees north of east. This method of adding vectors by connecting them tip to tail is called the triangle method or triangle law. Now let's apply vector addition to velocity. This is important when dealing with moving objects in different directions, such as airplanes flying in the wind or boats crossing a river. Imagine a boat is moving 4 meters per second east, while a river current is pushing it 3 meters per second south. The boat's final velocity is a combination of both. We use the same tip-to-tail method to add the velocity vectors and apply the Pythagorean theorem. So the boat's resultant velocity is 5 meters per second, and using trigonometry, we can determine the direction relative to east. That is 37 degrees south of east. So it is pretty easy to combine vectors by the triangular law. To find the resultant vector a plus b here, we start with joining the two vectors tip to tail and form a triangle. The resultant vector of a plus b is simply the third side of the triangle, with the direction from the other tail to tip, as shown in these two pictures. Now let's talk about vector subtraction. Subtracting a vector means finding the difference between two vectors, which is useful for relative displacement or relative velocity. If we want to find the difference of two vectors, for instance, a minus b, we simply rewrite a minus b to a plus negative b. Here, negative b is the opposite vector to b with the same magnitude. Then things become easy because it is transformed to vector addition again. Just as shown in the two pictures here, the subtraction of a minus b is converted to a plus negative b. Let's take an example. Imagine that a ship is sailing 8 meters per second due east, but a sudden gust of strong wind causes it diverted to another direction. Now the diverted velocity is 10 meters per second, with direction 36.9 north of east. So how can we find the velocity of wind? To solve this question, first we need to know the relationship between these velocities. We can easily find that the diverted velocity is just the resultant velocity of the boat itself and the wind. So we can say that v diverted equals to v sailing plus v wind. By rewriting the equation, we get v wind equals v diverted minus v sailing, or just v wind equals v diverted plus negative v sailing. And then we can use the triangular law. The velocity of wind is obtained. It is 6 meters per second with a direction due north. To wrap things up, vectors can be added by connecting two vectors tip to tail to form a triangle, and the resultant vector is the third side of the triangle. By using the Pythagorean theorem and trigonometry, we can find the magnitude and direction of the resultant vector. Vector subtraction can be done in the same way by converting minus a vector to plus the negative vector, just as shown in the figures. That's all for today's lesson. Thanks for watching, and I hope you now have a clear understanding of vector addition and subtraction. I'm Felix Michael, and I will see you in the next video.